Nowadays, turbines are kind of growing in size, and that's something that we all see. But we also place these wind turbines together in clusters, in what we call wind farms. Unfortunately, these wind turbines start to interact through the airflow when you start to place them close together. So there is more turbulence generated, so that leads to more loads. And also upstream turbines already take part of the energy out of the wind, and so downstream turbines don't have that much energy. So you actually have in wind farms two competing objectives. You would like to put a lot of turbines close together, but at some point that starts to hurt you because you have losses, energy is lost, and you have more loads. So if you think about wind farm control, what you try to do is control the turbines, let them interact in some kind of way. And the some kind of way, that's what the research is about, obviously. So you want to let them interact in some kind of way, such that you lose less energy, you have less loading, and so potentially you could bring them closer together and get even denser wind farm layouts. There is obviously various aspects that should be tackled, and there's not maybe one that is more important than the other, but essentially there is the physics that you want to better understand. You need to have faster, better models to represent what's happening. We know already that it's very complex and high dimensional, so you could use a supercomputer to try to get insight, but that's not something that you can use in a real-time setting for control. So next to the physical insight, you need also control models that are fast enough to really do something in your wind farm that you can use there. And then say that you could use wind farm control, that it would exist. The question is, how do you integrate that in your wind farm design? Because I was talking before about the fact that you want to densify maybe the wind farm, get more energy out of the same concession zone, and that is part of an overall design problem. So then you need to integrate these new types of controls into a new type of design of the wind farm. And apart from that, there is the big challenge, and I alluded to that already, of being able to sense, to understand what is the wind inside the farm at every spot or at every relevant location. And for that you need better sensing infrastructure, etc. So the grand challenges in wind farm control are basically related to the complexity of the problem. So this is partly still due to the fundamental physics underlying the flow, the aerodynamics of wind farms. So you have a very complicated, very high dimensional turbulent airflow through the wind farm. The turbulence interact with that and further add turbulence and complexity to the flow. And so it leads to an enormously complex, big control problem on the one hand, and also to a very enormously complex physical system that we don't even see because air is transparent, right? And it's also very difficult to measure. So it's very difficult to understand what is happening, and then if we would understand what's happening or be able to measure what's happening, then it would still be very difficult to predict then what exactly you should do to improve on the situation. So that's basically the fundamental challenge that you have in wind farm control. From an industrial perspective, if you look at wind farm control, there's at this moment also still a lot of challenges. And one of the biggest challenges at this moment is to just being able to benchmark whether wind farm control works or not, and what is the gain that you get out of it. Unfortunately, the weather is always changing, so you cannot just simply say, today I'm testing the wind farm control and tomorrow I'm testing the same farm without wind farm control, and by the difference I would know whether the control works, because over the day the weather will have changed. So from a statistical and measurement perspective, it is still very challenging to just quantify the gains that you make. So if you have a gain, let's say you have a gain of say 5% in energy extraction, which is huge in terms of the margin and the cost that you have of the system. That is very difficult to measure because of the large variability in a farm. So for the industry, I think the biggest challenge at this point is to get to a reliable testing environment on the farm to see whether the control works or not. Yeah, so obviously wind energy is very successful at this moment already. And it is actually technology that we want to push forward to do the green energy transition and to really replace coal-fired and oil-fired plants. However, there's still a lot of interesting opportunities. We can make this a technology that is, in the coming 20-30 years, going to be a lot cheaper still if we manage to handle the complex interaction between the wind farm and the wind system. Nowadays, we manage to do that, but we are still grasping and understanding the complexity of the physics, and somehow we managed to do that still at this point. But there is a lot of opportunity that we are not using yet in this complex wind system, and that is also where the wind farm control story comes in. So I think one very important aspect, and I mentioned that already, is obviously that if you have a efficient wind farm control, you could potentially, in a denser wind farm, alleviate some of the energy losses that you expect, alleviate some of the load losses, the load increases that you expect in downstream turbines, and so you may be able to densify wind farms. That's one, at least, prospect that we see. But there's much more to wind energy than just only getting as much energy as possible out of the air, because in essence the wind farm is part of a bigger electricity system, and so in that bigger electricity system, very often you need just a lot of energy, and you're happy to give that, and that's one possible objective. But other times you may just want to balance or help the system to balance itself, and so you may need to respond to demands from, let's say, the electricity infrastructure, the power grid, and also being agile and being versatile in the way you respond to this kind of demands is one aspect of wind farm control that will become very important in the future. Wind energy it's an incredibly complex discipline, and everything comes together. You have the power grid, you have the power converters, you have the generator, the machine, the gearbox, you have the full tower, the structure, the substructure, and then you have the wind system itself, the way the turbine interacts with the wind, the way the wind farm interacts with, let's say, the atmosphere, the atmospheric boundary layer. There's an enormous amount of disciplines that come together. There's also, let's say, environmental aspects, social sciences that play an important role. And so it's incredibly fascinating. As a scientist, you see, let's say, a little piece of that, and then you interact with other people that see another piece. And that process itself is already incredibly interesting. Also working with industry, they obviously go less deep in the specific question, but they have a view of the whole system. And also that interaction is incredibly interesting. It's one of, let's say, the most multidisciplinary systems you could think of. And it's, I would say, also one of the systems that you can touch, you can grasp with your hands. You may get the feeling that maybe it's not high tech. I can tell you it's one of the most high tech systems you can find in today's world.